Sure. Today we have the privilege having Jackie. She has an incredible and impressive background. Um, and the reason why we decided to bring her in is because she's well known as a person that has strong opinions, and she is uh, maybe I should have one of her friends describe her. She has, I was told she's without filter. So that right there, said, we don't filter, okay, she's not. So, she has an impressive background. She works for Cribble, who has been generous enough to support us. And she has, we wanted somebody that had, that would set the tone for the conference, and I'm absolutely positive, that she would do so. Would you like to say anything about,
I think you
Jackie?
said it, she has no filter, no filter, a woman in security. We need more of them, so it's nice to see women out there. Come talk to me, if you want to learn about getting into security or anything like that, but with Jackie, regardless of Cribble's sponsorship, wanted her to speak. Just because she's the voice of the next generation. She has an incredible background and she has no filter. She will tell you exactly how it is, which is what we all need in this world. So with that, Jackie.
All right.
And she's fun.
All right, while she sits up, for those of you who are playing the CDF, which is a no quarter CDF, remember to, when you register, obviously, if you're gonna win and go to the Hackbox place, we want the information to match, right? So make sure that, you put John Doe at johndoe.com, right? So, because I'm gonna ask you, we need to match it, right? So you can win, I think it's over $400, worth of subscription. So this is a very nice price and very generous from Hackbox to give us that. Same thing with Pen Testers. We have subscriptions for you. We will be giving out more during our monthly meetings. So every time we do our meetings, we try to either, if we have a vendor, we try the vendors to give something to our members. And we try that you leave home or you go back home with something to do. And most of all, that you learn something new. So again, please join us in our monthly meetings. Our next project is the Darkest Village, the ISA Conference 2023. We'll be running one of the sandboxes, and we bring a lot of the local community. Our intention is to get the next generation of people that goes and speaks of Black Hat, and speaks of ISA, goes to DEF CON and wins CDX. And we've been doing it now for a while, and we want to basically create more. So, so please, basically, if you go to meetup.com, /Pacific Hackers, you'll be able to see the actual content of our meetups. We do have an online platform, by the way, for those of you who are at zero. We do have an online platform that basically will guide you through what we believe is the basics and the minimum that you need to get a job in cybersecurity. So basically, we aim to turn you into a SOC 1 analyst. A security operations analyst is usually the first job that most people get in cybersecurity if they get hired. From there, you can choose if you want to be a pen tester, if you want to be a blue teamer, a red teamer. There will be all kinds of subjects. If you actually look at the meetup page and you are able to see the past meetings, we do have a curriculum. It's not a formal curriculum, but it's definitely some of the subjects that we believe will get you there. Ready?
Yes.
All right, so here we go.
Hi, I'm Jackie. I don't know how to start talking after that intro. I guess I have no filter, apparently. That's a theme. Nice to see you guys. So I'm Jackie McGuire. Thanks for having me. I am so honored to be here. I can't explain how much I love working in cybersecurity, and the entire reason that I love it is, one, it's this never-ending puzzle to solve. But the people that you meet working in security are the weirdest, nerdiest, smartest, coolest people. Being a little bit neurodivergent myself, I really identify with a lot of the personalities in security. So I have had more fun working in security than any other job, but I want to actually tell you guys about how I got into security, because I think most people who come into cybersecurity don't do so directly. Very few people end up in here and end up in this industry the traditional way. So I got my start, sorry, my Zoom bar. I got my start with computers when I was little. Grew up pretty poor, and my mom would go grocery shopping with me in the strip mall that had a Radio Shack on the end. And at 3 or 4 years old, she would literally just drop me off at Radio Shack and then go grocery shop. And the guys at Radio Shack were nice enough to teach me how to use a computer. So I used to mess around with Windows on their computer for an hour or two every week. So I kind of had access to a computer from a pretty young age. And then my mom started law school when I was 9. And again, no money for a babysitter, so she parked me in the computer lab at the law school. So people at the law school were really nice and taught me how to use a printer. They taught me how to use a mouse and a keyboard. And I remember the first time I moved an icon on Windows, I thought that I had fucked something up so badly that nothing was ever going to be the same again. So I actually went into Wall Street and straight out of college, actually during college by accident. So I was going to school for psychology, didn't know what I wanted to do with my life, saw this job on Fidelity's website that said financial representative. I didn't even know what a mutual fund was, but I applied for it, bullshitted my way through the interview, and somehow ended up becoming a stockbroker when I was 20. Yeah, it was great. This is 2005, so I kind of cut my teeth in the run-up to the financial crisis, and then was lucky enough that I had just been loaned from my team to Fidelity's fixed income desk the day Bear Stearns went bankrupt. So I got about 10 years worth of experience in a really harrowing couple years in finance, then moved over to Silicon Valley Bank. And that's actually how I met Hacker Dojo. So SVB heard me explaining municipal bonds to my husband, somebody from SVB, in an airport bar. My husband's an engineer, so I was explaining municipal bonds in an engineer way. And they stopped me and said, hey, we need somebody who can do this for CFOs, CEOs, and boards of director and help them manage their cash. So I started working at SVB, and I really kind of caught the tech bug. I was working with all these great startup companies. Actually met Hacker Dojo and the team here when just a couple years after Hacker Dojo opened, because they held all these amazing meetups and workshops for startup founders. So I decided to leave finance, and I knew I wanted to get into tech, but wasn't sure what I wanted to do. And through my whole career, the theme that was recurring to me was that even with good data, if people don't have good context for the data, if they don't understand how to think about it or how to compare it to things they're already familiar with, people will make very bad decisions. And I saw that in finance during the financial crisis. I saw that with the tech companies that I helped, who would literally leave $500 million sitting in their checking account. So I thought, well, if I could do a better job of understanding and manipulating data, then I could probably understand the world. And I also really wanted to learn Python and already understood statistics. I had gotten an economics and finance degree by this point. So I became a data scientist. I went to the UC Berkeley Data Bootcamp. And for my capstone project, I took 1 million book cover images from Amazon, and I fed them through image analysis and then associated the analysis with their rating. And I created this really cute model that would literally judge your book by its cover. So if you uploaded a picture of a book cover, it would say, based on your cover alone, this book is likely to be a 3.2 on Amazon. Didn't really think much of it, and actually ended up getting recruited to an AR company, and we actually won TechCrunch Disrupt in 2018 to do AR stuff. And then this guy reached out to me and he said, hey, I just got hired as the first data scientist for this SIM vendor who's writing SIM is a SIM for basically core banking systems. And given your background and your project that I saw, I think I put it in one of my code repositories, it's like, we would love to interview you. So I was like, oh shit. So the highest level of math I took in high school was Algebra 2. I never thought I was going into anything statistical. So the week before my data science interview, I took the MIT Applied Calculus for Data Science class. It was a lot, and apparently I over-prepared, but I learned so much. And what I learned was that sitting through a class is never really as valuable as getting your hands on a keyboard. Is never really as valuable as applying the concepts and the principles that you know to actual problems. And so where I had really struggled with algebra and calculus and trig before, all of a sudden now that I was applying it to data science, it all made sense. So I became a data scientist for this sim vendor. And what I did was I wrote anomaly detection. So I wrote these neural networks that would kind of do sort of what Zero Trust is trying to accomplish right now, make these context-based decisions on not just, are you inside or outside the firewall, or do you usually access this application, but do you usually access this application at this time from this computer? So creating more robust kind of user behavior analytics. And it really kind of got me back into computers and cybersecurity, right? And I started meeting all these really cool people. And so that's how I got into cybersecurity. They went on to patent a couple of the anomaly detection and UEBAs that I wrote. And then I ended up moving to S&P as an analyst. So I covered this industry for a couple months. And then my boss, who just showed up and brought me coffee from Starbucks, which is, can you really ask for something good than that? He happened to brief me on Cribble. And as a data scientist, one of the things that I just freaking hate is that I would spend a week or two with every new model, just trying to get the data into something I could understand and use with regex and just all of that. And what Cribble did was made a lot of that obsolete. So that's how I ended up where I'm at now. And I do market strategy. So it turns out I'm a human translator. I don't know about having no filter. That's probably true. But I can translate from nerd to executive, from customer to engineering, from engineering to customer. And so what I do is kind of understand the security market and what the market really needs and what problems really need to be solved. And then our company tries to solve them. So let's see. All right. So what I wanted to talk about today, kind of before I get into the technical part of what I'm going to talk about, is coming together. So this is the first time we've been back in person, and I think we've all attended a bunch of virtual events over the last couple of years, and they're okay, but nothing really beats being in a room with a bunch of really freaking smart people, and then you add some substances and things get really fun, right? So I think that the reason that hackers are winning, and they're winning, like we're screwed. I mean, the state of security is not pretty, right? We have like 80% of companies have had some type of malware or ransomware incident in the last 12 months. Most of them are just paying the ransoms and trying to move on. And it really occurred to me a few months ago that I was reading this thing on the dark web where you can buy ransomware exploits for $5 or $10. They're insanely cheap. Some people will just put them out there for free because some men love to watch the world burn. And so what hackers have done is they've open sourced everything. They're sharing information. They're working as groups. They're not competing. They're collaborating. And they've created this open source playground where people can do their best work for terrible reasons. Security has done the exact opposite, right? We've spent the last 30 years building silos, being anti-competitive, creating proprietary languages that are a bitch to learn, and just generally not doing a great job working well together. Most of our security stacks look like they're put together with kind of duct tape and bubble gum. And nobody's out there really trying to solve this problem of, hey, we need to work together. So in the last year, I shouldn't say nobody, because in the last couple of years, we've actually started to see that tide shift, right? So we have this new OCSF, which is this great framework for how we should be thinking about security data and formatting it. A lot of companies are moving into the, oh, we're multi-cloud, we support lots of things. So I think we're moving in the right direction, but the people in this room right now are the key component of winning this war. We are never, ever, ever going to accomplish anything if we don't all advocate for open source, advocate for common protocols, advocate for better sharing of information. Cribble as a company is dedicated. We provide free certification. So we have a couple different levels of certification, and we have already committed as a company that all of our training and education will be free forever, because there should not be a barrier to you learning how to do a job or learning how to be better at your job. So I think we really need to start thinking about how we support ourselves as a community. One of the things that I get asked all the time is, how do we get more women into cybersecurity? Well, the answer is you can't be what you can't see. And until we start coming together more and being more visibly united as women in cybersecurity, as non-binary people, as the amazing freaky geeks that we are, which is why I love working in security, We're not gonna be able to hire the 5 to 10 million analysts, 5 to 10 million analysts just to solve the shortfall in the next 5 years. So that's my spiel about coming together. So really happy that we could all be here. And now I want to talk about technical stuff. All right, so the way I think about kind of the evolution of security and threats is, in the beginning, we had a firewall and then antivirus, right? It was like, as long as we keep everybody out of the firewall, we'll be fine. And then the antivirus will solve anything that somebody clicks we don't want them to. But realistically, there were holes everywhere and everything was getting through and they're around. So we said, okay, we need a new method. And we developed tool upon tool upon tool upon tool to solve very specific feature type issues. And now we have this insane cluster of tools, but there's still gaps. And instead of missing threats because we can't see them, we now miss them because we have 1,500 false positive alerts that need to be triaged. And as an analyst, the last research that I did last year showed that 24% of alerts are actually even being triaged. So we're not even looking at 3/4 of the stuff that our tools are surfacing. So the question is, why do we even use them, right? If we're not actually going to use the data that they produce. And then, the connected world is a beautiful thing, right? I am one of those people that I embrace technology wholeheartedly. I love all of my smart devices. Everything in my house is connected, but we're talking about 45 billion devices by 2025. And each of these devices produces logs, metrics, trace, all this data. So as you can see, over 64 zettabytes of data was created or replicated in 2020, and that's growing at 25% a year. So we're probably a lot closer to over 100 zettabytes at this point. And again, we're not looking at the vast majority of it. So I'm a former analyst, my boss is a former analyst. So we thought, what's the best way to figure out what the hell people are doing to try to handle this? And we did a survey. So we surveyed like 1,000 security professionals, CISOs, VPs of security, and we're like, what are you doing? Like, what does your environment look like today? How are you addressing some of these problems? And I think what's interesting that I took away from it is that security teams are actually working really closely with IT teams, which has not always been the case, has not always been the most symbiotic of relationships. And they're also managing a lot of tools. We'll talk about how many in a minute, but still not really building sustainable architecture. So this is kind of mind-blowing for me. So 63% of the people we surveyed, so roughly 600 of these people, said their strategy was sustainable for 3 years or less. And half of those people actually said their strategy was sustainable for 12 months or less. But they said that they are very confident in their strategy. So to me, that says that we have started to define success in how we manage security data, as we're just dealing with it 12 months at a time, if we're lucky. If we're lucky, we're dealing with it 12 months at a time. And that is not a great position to be in. Yeah, and so those people who are very confident in their strategy are using more than 25 tools for visibility and adding more. And I think that is a very common thing that occurs, is that if there's some type of snafu, instead of RCA and fixing the root cause of the problem, we buy a tool. Because we're like, well, clearly our SIM screwed up, or our source screwed up, or it's our EDR. It's probably the way we're managing security as a whole. And so retail therapy is alive and strong in security. This one, so coming into this survey, I was telling my team, IT and security just doesn't really play well together. And so this company started as an observability company. And I said, well, observability is kind of an IT term, and we don't really play with IT that well. We don't want them in our budgets. We don't want them in our buying processes. And so we did this survey, and it turns out I'm wrong. And whether this is because new people are coming into the market that don't have these kind of pre-existing dysfunctional relationship ideas, or I was just wrong all along, 90+% of people say that they actually work really well and really closely with IT. And we've always said all data is security data, and it sounds like we're starting to kind of agree. So I kind of identified three real areas that are causing people to not be as efficient and productive with their security data as we want them to be. The first is a lot of people have data they just can't see. So I know you guys are all on point with all of your naming conventions. You have documented processes at your company, so no one ever names something that they shouldn't. All usernames are the same. I hate to break this to you, but some people don't do that. And when you try to do incident response and you're trying to figure out how many different things this account has touched, if you don't have a great way to access all of the different ways that this user is identified, you're going to have a really hard time gathering the information that you need. And then even if you can gather it, a lot of us can't afford it. So I met with a university 2 weeks ago, and they told me they weren't capturing their web requests at all. And the guy was like, I know that's terrible. It's literally our single biggest attack surface. Students are the problem. But they're so voluminous. Same thing with network flows, right? Like this is where attacks show up. I always say to people, like, if you robbed a bank, you wouldn't go run into an empty building to hide. You run into a crowded room. So when we think about, okay, as an attacker, what are the logs that are the easiest to cover my tracks in? They're the really noisy ones, right? So web requests, network flows, DNS request and response, that's a big one, right? And it's a really kind of bulky log. So a lot of companies, so on the observability side of things, we originally had like a return on investment value. So, hey, if you spend money, we actually save you money on the data you're ingesting. It turns out in security, we don't actually want to save money because none of us want our budgets cut. What we want is to get more data in. And so what we're finding is that when people reduce the crap in the data that they're bringing in and reduce the size of the files that they're looking at, they don't actually just spend less on their SIEM that's ingesting them. They onboard all of these data sources that they really should have been looking at and weren't because they couldn't afford to. And so raise your hand if you love regex. All right. From now on, instead of relearning how to write regex every time I need to, I'm calling you. So I met with a customer the other day who literally had all these heavy forwarders that he was doing these insane regex things in to try to handle his data but not until it hit the cloud, right? So we're talking about you're paying to ingest the shit data, then doing a bunch of regex and paying to do that just to get a reduced amount of data. And the thing is that when you handle things inline, not only do upstream changes break downstream inline code, the other thing is that this bloat. So as a data scientist, I didn't think about like, oh, it's 3 extra lines of code, because it's just 3 extra lines of code. But when that 3 extra lines of code is running every time a log that produces 10 million logs a day comes in, that's not 3 extra lines of code. That's 30 million extra lines of code. And one of the things I think is interesting is we were kind of told like the cloud is going to solve all of our problems, right? You don't have to buy more servers. You don't have to, it's endlessly scalable. It's wonderful. That's totally true in some ways. The thing with the cloud is that it's completely removed us from the actual impact of our actions. So when I was a new data scientist, I was looking at syslog and I needed to train a neural network and I hit a button. I was like, this is going to take forever. So I went to lunch. I came back, $75,000 AWS bill. And luckily Amazon was cool about it and they refunded the money, but I basically had just not limited the amount of logs I was pulling and pulled millions of logs into this neural network and just, and so there are a lot of issues with the way we currently handle noisy data. Not only is it inefficient, but it also costs us a lot of money that we don't necessarily see. And I can't wait till we get to a point that we can actually tell you before you do something. That we're kind of running off the rails. So here's the last thing. So data that we can't use. So like I said, you can give people as much data as you want, but if you don't give them context or help them understand what they're looking at, they will make very bad decisions. So if you're just collecting IPs and you're not doing any type of data enrichment, you're not collecting geolocation, you're not counting how many times this IP has shown up, what's the point? And incidentally, one of these IPs is actually from North Korea, I think. The other thing is that this log says it's from October 22nd, 2020. It may be, but it's probably more likely that somebody fucked up the timestamp. And I know none of you have misconfigured timestamps on any of your endpoints, firewalls, anything like that, but one, not only so most timestamps are done really inefficiently, so firewall logs is a great example. I'm not gonna name names, some companies' firewall logs have like 3 or 4 timestamps in the header. And so we find with those companies, we can literally just drop the header, standardize the timestamp, and reduce like 1/3 of that log size. So these are things that are not only best practices, but they actually help you do your job much more efficiently. And so how do you do all this, right? Like this is all great in theory, but how do you actually accomplish it? So what Kerbal built was called a security data pipeline. And essentially the concept here is separate the system that analyzes your data from the system that collects and retains it. There's a lot of reasons that you want to do this, but this one is my favorite. I love Lucky Charms, but I actually don't really like cereal. So what you can do with a data pipeline is say, I am a bit of a sugarholic. I really don't like cereal. So what I want to do is I want to take my Lucky Charms and I really just want the marshmallows. But my family kind of likes Lucky Charms. So it's possible that I want to keep the box somewhere, but I don't want to just keep a bunch of marshmallows somewhere because they're going to go bad, right? So I'm going to take the marshmallows that once you pull them out of the cereal, kind of dry up and get gross. I don't know if you've ever experienced that, or they get moist. And the time sensitive marshmallows, I'm going to throw that through my analytics tool in my mouth. The rest of it, you can stick in object storage. So the equivalent of how we handle data right now is like if every time you flushed your toilet, your shower and sink turned on. Like that's kind of what we do with logs. We put everything through the SIM or none at all for the most part. And so what we're saying is if you really only need marshmallows, why have the extra calories of eating the cereal if you can eat twice as many marshmallows? And then, but you're like, okay, that's great. But what happens if I didn't pick the marshmallows out of this certain type of cereal that I needed? So what's great is with a data replay, you can go back into your data lake, take that data back out, and then send it through your analytics tool, be it Cortex, Splunk, CrowdStrike, wherever you're sending that data, and actually do all of that hardcore analysis to it if you really need to. So if we're doing incident response, we're trying to, and we can replay full session packet capture. So you can literally watch the packet capture in real time as if the session was going on right now. So you don't ever lose access to that data. You're just not paying through the freaking nose to put it in your SIM. So this is kind of what security looked like right now. We had all of these sources of data, each with their own agent, sitting on an endpoint. And almost all of these agents send data to one place. So it's kind of the equivalent of every single, I use water as an analogy for data because I think it's really kind of similar. So it's kind of the equivalent if every single sink and toilet and shower in your house had its own individual pipe coming off the street. It's just, it doesn't make sense and it doesn't really work that well, right? So what we've proposed is why not take all of those sources of data and either use our universal agent, which can replace many agents and actually improve endpoint performance by not running 15 agents on the same endpoint, or use the agents that you have, but send this data to one place, process it, clean it up, reduce it, figure out what pieces of it need to go which places, and only send those pieces to those places. So when you talk about something like DNS requests and responses, where it's like a 200-line log and you're interested in 30 lines, if you need to retain that 200-line log because you're a government agency, you are highly regulated, whatever the case may be, you can just stick that whole thing into a data lake and only pay to put the good stuff through the tools that actually do what you want to. And this is my other soapbox moment about why this is important. So I am not just cranky, and it's not just that I like my Python written efficiently. The cloud surpassed the airline industry for carbon emissions in 2020. A building at a data center campus uses as much electricity as 50,000 homes, and the average modern data center campus has 8 to 12 buildings. So we're talking about using 500,000 homes worth of electricity per data center campus. And we are building data centers at an insane clip. One of the things that has happened with AI and machine learning is that we used to build data centers to store data and to do basic computation, and we are now building some data centers almost exclusively for AI and ML. And that's great, I guess, if it's being used for the right reasons. But we really need to be more conscious of the impacts of our actions with data and computational power. Every single hertz of computational power has an effect on the environment. And because we've had to start, there's all these interesting kind of back and forth whipsaw effects, right? So GDPR was seen as this great solution for privacy. What has happened with a lot of these privacy regulations is they are now forcing data centers to be built in climates that are not meant for data centers. Data centers are meant to run in somewhat cool, very dry environments because they actually use water for most of their cooling. We're now having to build data centers in places like Singapore. Singapore is very hot, it's very humid, and also you can't build out. So we're having to build vertical data centers now. Vertical data centers, if you can imagine the amount of heat that a regular data center produces, the top floor of a vertical data center is going to be that times about 20. So we are now building less efficient data centers. We're building more of them, and we are just throwing AI and machine learning at every problem that looks like it might be a good fit. So my big plea to you is using Cribble or any other data pipeline. There are others that exist, but mostly DIY kind of solutions. Is also really good for the environment, and that's really important to me. All right, I am done. I'm happy to take questions. I only swore a couple times, which is a kind of accomplishment for me. This is a link to the full security report. So if you want to read all of our research and all of the, it was about 25 questions, I think. You could access the full report and take a look at kind of how people are managing their security data. But otherwise, I'm happy to take questions. And if nobody has questions, I'm happy to walk off. Okay. Yes, I will share this presentation. Yes.
On the stats you presented from the report, where there's 91, 92%, the security teams work with IT teams now. What do you interpret that to mean?
So I think what's happened is that there's a little bit of economic necessity to it, right? So what Cribble has found is that typically if people start using us for observability on the IT side, they end up using us for security. And I think that's the case with a lot of tools that kind of span, if you think about that span kind of IT and security. So I think what's happened is it used to be that security, because security didn't look at all enterprise data as security data, there was security data that they controlled. They had, in warehouses or data lakes or databases, and then there was IT data, and they were very much and again, this is my probably early 2000s viewpoint of things, but they were very much segregated. And I think now, both because all enterprise data is really security data, because hackers are smart, right? We all were like, all right, they're not looking at this, I'm just going to go there and do that. So I think that, and then economically, we can't afford to have 3 different tools looking at the same data, because security wants their own tool, and IT wants their own tool, and network ops wants their own tool. So I think some of it is kind of economically driven at this point, but I also think it's just the nature of understanding that all data is security data. Yeah, go ahead. Triage, yeah.
And so I heard years ago about the accuracy rate.
Mm-hmm. So I don't have one on accuracy of alerts, but that's so kind of coming from data science, where I wrote the things that do these detections. That's really what we're trying to address with the data pipeline, right? So one of the reasons that you produce a lot of false alerts is that when you feed non-pertinent data to a model. So for example, if you feed machine ID or anything else that has a variation, but doesn't actually, the variation isn't a feature of the model, meaning it's not an indication, you get false positives. And so machine learning is still kind of this fungible thing that we're trying to throw at every problem to see if it can tackle. And so the whole point of feeding just marshmallows to your sim is that it won't freak out if one of the Lucky Charms cereal is the wrong shape or color, right? So that's kind of the whole point of boosting signal to noise, is to get more accurate alerts, because you're absolutely right. bad and noisy data causes a lot of false positives, but it also causes false negatives. And you lose legitimate threats to the model not understanding them. So, but I was an analyst for S&P Market Intelligence, and we did a survey to address what you're talking about. So I can see if I can find that for you, but it's not our stuff. Yeah. Awesome. All right, I think I might have gone way over time. So thank you guys. Please. I also want to be one of the people. Cribble is hiring, by the way. So Cribble has several security positions open, cribble.io/jobs. If you see something you like, please feel free to come see me right now. Feel free to hit me up on social media or email me. We're growing really fast, doing really well, and would love more smart people on board. Thanks, guys.
Thank you. All right, that was pretty awesome. Thank you very much, Jackie.